So hello again, and here we go with another pretty much unscripted thing. I wanted to talk about a few things today. Go through a lot of kind of cover a lot of ground. So I'm hoping I can do it enough justice. But like I say, with these things, it's I don't have a script to go by, so there's a very good chance I'll forget things or. But yeah, no. So, proof of God from outer space. I'm going to go through a bunch of arguments, reasons to believe that God exists based on astronomy, science. Yeah, astronomy. Astronomy really is from space, so that's what I'm doing here. So I'm going to go through. I've got the Kalam, I've got the Contingency, I've got the teleological, and I've got a couple of extras that you'll have to just wait and see to keep till the end. So, where do we start? And this is where I wish I had a script, because I was going to do this in a certain order. Yeah, I'm going to start with the Contingency. Yes. Okay, so this is the argument from Contingency. So it's set up in the steps here. It's kind of evolved over the years, but it's always been around. Been around for a very long time. So first, I put it up on the screen here, but let's read through it to make sure we've all heard it. Everything that exists has an explanation of its existence, either in the necessity of its own nature or in an external cause. If the universe has an explanation of its existence, that explanation is God. The universe exists. Therefore, the universe has an explanation of its existence. Therefore, the explanation of the universe's existence is God. Okay, so this is sort of a step-by-step thing of building up how you get to this conclusion of God's existence. This is called a syllogism. So you use premises to build up to a conclusion. The way this one's set up isn't how you normally would do it. You normally have the premises and the conclusion. This is a perfectly valid way of doing it, though. So let's start. Everything that exists has an explanation of its own existence, either in the necessity of its own nature or in an external cause. So that's straightforward. Something comes into existence or starts existing because somebody built it or made it or created it or birthed it, or you know, it could be a natural thing like a tree growing an acorn. You know, something grows out of something else. Nothing just starts existing out of thin air. You know, nothing just out of thin air might be the one, because air can, it's got molecules and things going on. So, but nothing just, you know. The example Dr. Craig likes to use is, you're not walking around constantly in fear of tigers just appearing on the high street, because that just doesn't happen. There's got to be a reason for the tiger to be where it is. You know, so there's either the things are made or birthed or grown in some way out of a parent of some kind. I'm trying to be careful with the words I'm using, because if I keep saying created, then that's too, you know, when it's not necessarily creation, it could be this natural growth. It could be natural elements, chemicals reacting together and producing something. Produced is a good word. There we go. How about produced? Produced by something else, not necessarily created. It could be perfectly natural result. Unless these things, you've got things that are always produced by something else, unless they are something that have to exist. Just they cannot not exist. So a lot of mathematicians would like to say numbers are in this category. So that 1, 2, 3, 4, 5, whatever you call them, in English, I just said them. Greek, ena theodria, French, under toi. Doesn't matter what you call them. These words are describing some reality, something in reality that's there and cannot not be there. 1 and 1 will always make 2 because it cannot not do that. There's no way 1 and 1 could be 3. It's just basic kind of logic. It can't be any other way. So these are the options. Either something is produced by something else, or it just has to be there the way it is. So we're saying if the universe has an explanation of its existence, that explanation is God. Should we come back to that one? Because the next one's very easy. The universe exists. We can all agree on that one. Therefore, the universe has an explanation. So if the universe exists, it needs an explanation either in its own nature or in the external cause. And based on premise 2, basically, because 1, 3 and 4 are all very, very easy to accept. So everything hangs on number 2. If number 2's right, then number 5's right. And there we go. So this like I say, this goes back quite a long way. It's very similar to Aquinas' second way, which I'm just going to read out for you very quickly right now. The second way of his 5 ways is from the nature of the efficient cause. In the world of sense, we find there is an order of efficient causes. There is no case known, neither is it indeed possible, in which a thing is found to be the efficient cause of itself, for so it would be prior to itself, which is impossible. Now in efficient causes it is not possible to go on to infinity, because in all efficient causes, following in order, the first is the cause of the intermediate cause, and the intermediate is the cause of the ultimate cause, whether the intermediate cause be several or only one. Now, to take away the cause is to take away the effect. Therefore, if there be no first cause among efficient causes, there be no ultimate, nor any intermediate cause. But in efficient causes it is possible to go on to infinity, there will be no first efficient cause. Neither will there be an ultimate effect, nor any intermediate efficient causes, all of which is plainly false. Therefore it is necessary to admit a first efficient cause, to which everyone gives the name of God. My computer wants to install some updates right now while I'm trying to use it. So that was the way it was put by Aquinas there. It's a bit more plain English the way I've got it up here. So hopefully that was understandable. Best way to explain it, I think, if I pull this way, let's by way of an analogy, yeah. So if you've got a row of dominoes, they're not going to go anywhere until so you see the wobble, still the little red turning thing. So there's this dominoes falling here. There's a whole string of events happening, knocking one down, knocking the next down. They're all sequential, okay? So now we're on the blue there. The blue's falling, the red's falling, the darker red's falling, the pink's falling. The pink's falling because the red fell. The red fell because of the other pink. So they're going in order. So the reds wouldn't fall without the pinks falling. The pinks wouldn't fall without whichever colour came before that. Let's say that the pink's falling just because of the green there. So if the green didn't fall, the pink wouldn't fall. The pink didn't fall, the red wouldn't fall. The red doesn't fall, the yellow doesn't fall. The yellow doesn't fall. So somewhere one of them has to start. One of them has to start the link. And in this there was that thing at the top again, that red thing that turned around and poked, which was it was different. It wasn't a domino. It was something different. So this is what Aquinas is talking about with the intermediate cause and the ultimate effect would be talking about the last one. It's not using ultimate in the sense of like the best. This is the ultimate. We're talking about ultimate as in the last one. So, and then the intermediate is then everything between the last and the first. So the ultimate, the last, isn't going to fall down without the intermediates. If whether there's one, whether there's however many we can see here, and the intermediates aren't going to fall without the first one. So a sequence of events assumes a first event. If you don't have a first event, it's going on to infinity. But if you go on to infinity, there's no first. So where does the falling start? The falling has to start with a first. There has to be a first. You just can't go on to infinity. You can't do it. It doesn't go. It doesn't work. So that's that. So what could the first cause be? So then we go back to the syllogism. We had the premise one there was the explanation being its own nature, being necessary nature, or being part of this chain of events, or things being produced by other things. And if it's the first one in the chain, then it has to be one of these necessary things. One of these necessary things that can start the chain. Otherwise, those are the options. You're the necessary, or you're in the chain. So we're saying that the first thing can't be in the chain, it's the beginning of the chain. So we need something necessary to start the chain of events. What could that be? What could that be? And so we have this answer, God is the answer. Because he's the start of everything. This is where Aquinas is saying that this is just the thing we call God, because it's where everything else has come from, because we're talking about like ultimate everything, life and existence and creation. It's all come from this one place, and what could possibly be the source of that? So it's a little bit sort of vague on the details, but that's okay, because the argument isn't meant to get you to any specific theology like Christianity, for example, Islam, whatever. It's just getting you like, okay, something is the first in line of the chain of events, and that something is a necessarily existing being. And what would this necessary being look like? Well, it's something that can create, something that's powerful, something that's kind of all-encompassing. So the properties it has to have to be the beginning of everything, it starts to make this picture of what we understand God to be. Okay, so that's contingency in a sort of nutshell there. Oh gosh, that's still going. Anyway, you can find the rest of that on YouTube. World record attempt at dominoes. It's lovely, lovely stuff. Maybe I should tell you where I found that, so you can look it up right quick. It is on a channel called Hevesh 5. Hevesh 5. So I should give them the credit for making that wonderful thing there. So that's the contingency. That's kind of very straightforward. I mean, it was a little bit messy with it, and there's it's all about this chain of, it doesn't matter what it's life or creation, or we're talking about why is there something, why does anything exist? Why do we individually exist? Why does the planet exist? And why does the universe exist? It's part of this chain of events. What could have created that? Okay. So I don't spend much time on the contingency argument, because so I prefer this one. I think this one's a bit more solid with the way you can explain it. So this is the Kalam cosmological argument. You may have heard of it. I'm trying to do these quickly. I don't know how long I've been going already. So we've got the syllogism here again. This time we've got P1, P2, premises, and C for conclusion. Premise 1, everything that begins to exist has a cause. Premise 2, the universe began to exist. Conclusion, therefore the universe has a cause. Now, it's sort of similar to the last one in some ways, but you probably notice this one doesn't mention God anywhere. It's actually theologically neutral. So we've got here, everything that begins to exist has a cause. Is very similar to the contingency idea of the chain of events. Everything that exists, everything that began to exist was produced by something else. You can't just have a tiger popping into existence in the street. Doesn't happen. Something needs to make the tiger appear. Okay, so there's that. Premise 2, the universe began to exist. And if that's the case, if the universe began to exist, and everything that begins to exist needs a cause, then the universe needs a cause. Lovely and simple. So I like this one. Premise 1, everything that begins to exist has a cause. That would be the scientific principle of causality. So causality is how we can do science, basically. Every time you do an experiment, a test, you expect it to have a uniform result. If you do the same test over and over again, you're going to get the same result over and over again because of causality. That if causality wasn't a thing, a predictable thing in that way, no one could do science. Everything would be random all the time. So this is a core principle of science, is that causality is real. So premise 1 is causality. Premise 2, the universe began to exist. Now this is the Big Bang Theory. So here, premise 1, principle of causality. Premise 2, Big Bang Theory. Or we can kind of look at it in the same way as the dominoes again. This infinite regress that doesn't make sense. So either way, premise 1 and premise 2 are very much some of the strongest science we've got. So if you want to deny this, you have to be very anti-science. Because denying premise 1 just undermines all science. And denying premise 2 denies all of astronomy, cosmology. So so you have to be very anti-science. And then, like we said, this is a theologically neutral conclusion. The universe has a cause, so that's just an open question at this stage. So, okay, the universe needs an explanation of some kind. So, what could the explanation be? But before we go into that, let's some people do like to have a go at this. The first premise, I think, can be attacked sometimes by some people, but again, you're attacking the most fundamental principle of science, causality. Why would you do that? So at least with the second one, you're attacking the Big Bang Theory. That's a theory. I mean, it's a very good theory, a very strong theory with tons of evidence. Why would you? But that at least has potentially some wriggle room for you to be like, oh no, here's an alternative theory that fits the evidence better, or explains it differently. At least there's a little bit more wiggle room there, but still it's not very good because here we go. So the people that would attack it would be saying things like, no, the universe didn't begin because maybe there was some kind of I know a couple of decades ago people were talking about the Big Crunch. And it was a good episode of Red Dwarf as well, where the idea was, at the moment we're in the expanding stage of the universe. It gets bigger and bigger and bigger until it can't get any bigger, and then it starts to collapse back into itself until it's back to the Big Bang stage, and then it's forever, for eternity, in and out, in and out. So time goes forwards, it gets as big as it can't go any bigger, so time starts going backwards in reverse until it gets to the singularity again, and you just have that going. So that's one of the alternatives people sometimes put forward. But it would seem like the people who are in the business keep saying, that's an idea, but it's not an idea that flies. So here we go. We got a quote from Hawking and Ellis here. Almost everyone now believes that the universe and time itself had a beginning at the Big Bang. So this is space-time is a lot of people think time is just this measurement. It's just something arbitrary we come up with so we know when we can have appointments and we need to be there at a certain time. But time is actually this malleable, real, physical thing, which is bizarre sounding if it's the first time you've ever heard it. But apparently different I was about to talk about animals, but because different animals have different perceptions of time. But even within humans, if you remember back to when you were a kid, an hour felt like forever. But now an hour just shoot like at the older age, an hour can just shoot by. It's gone. So where did I go? I wanted to do all these things. I should be able to do all these things. I remember being able to do loads in an hour when I was a kid. Why can't I do that anymore? And it's something to do with how we perceive and interact with time. You know, the whole theory of relativity and so on. It literally relativity. The time is relative to subjects, so we interact with it differently because it's not just a measurement, it's a real thing, and it began at the Big Bang, according to Hawking. Time started then. There was no time before that. Time and space. So space. Yeah. I think I was going to actually show this stuff later, but I'll show it now. Who cares? It'll be relevant later anyway. So Vilenkin, same thing. There's a theory, the Bord-Guth-Vilenkin theory, and this is a great quote. Maybe you've seen it. With the proof, so they've done all the studies. They've looked at various models, the cyclical ones, and all that. Big Crunch, all of that. With the proof, there's more to this quote. It's cut a bit off. I should remember the bit before it. So it's something like. They say evidence is what it takes to convince a reasonable man, and proof is what it takes to convince an unreasonable man. But now, with the proof in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There is no escape. They have to face the problem of a cosmic beginning. So these guys, they've done all the work, and they've said, sorry guys, this cyclical stuff ain't gonna work. We've got a beginning of space-time. The universe had a beginning. What are we going to do with that? Next one. So Roger Penrose, again another leading name of cosmology. The conclusion to be drawn from the singularity theorem is that, according to classical general relativity, the universe must have had a beginning. Now, I'm pulling this quote up here because I think one of the responses to this would be like, well, we're not using classical general relativity when we get to this stage, so maybe we can find a way out of it with quantum theory. So that's fair. But it still doesn't get around what everyone else is saying. You know, there is this cosmic beginning. This is where Penrose, he's agnostic, I believe. So I think he is looking. He's always being a good scientist. He's trying to find. Okay, it looks like right now there's a beginning, but if we keep digging, maybe there won't be. But we don't. At the moment, it looks like there is. Is what he's saying there. So until any better evidence comes from, and the idea that there isn't, like we're looking through the quantum stuff, they haven't found an answer in there yet. They're looking because there are some people who want to avoid this conclusion. We've got another one. If we extrapolate this prediction to its extreme, we reach a point where all distances in the universe shrink to zero. He's talking about the singular. An initial cosmological singularity, therefore, forms a past temporal boundary to the universe. We cannot continue physical reasoning or even the concept of space-time through such an extremity. For this reason, most cosmologists think of the initial singularity as the beginning of the universe. So there he's talking about time doesn't go past the singularity. Space doesn't go past the singularity. Space-time is a thing. Space-time is a thing, and it began at the Big Bang. And one more here. The universe began from a state of infinite density. Space and time were created in that event, and so was all the matter in the universe. Okay, so this is seems like a general consensus among the biggest names in the field. The universe had a beginning, and the universe is defined as space and time and everything physical within it. So that's very important, and I'm going to show you why that's important. Because this, like I said, this is theologically neutral. This doesn't get you to God. This, you could say, okay, the universe has a cause. Maybe the cause was the Big Crunch. Maybe the cause was a multiverse. Maybe the cause was an alien. I don't know. What are these people talking It's nonsense, whatever it is. So I have we generally, and it's a weird thing that a lot of people do, is they'll tell you about this bit, but they miss the next bit, the important bit. And where have I put it? So if I put that one away and pull this one up, so this one's 12 points. So the first part P1, P2, P3, that's the same, because you need this extended section. So the conclusion for them, the previous becomes premise 3, which is P1 and P2 together. The universe has a cause. So what could the cause be? If the universe has a cause, it means that it's a new thing. It's being produced by something else. And the scientists have just said, space and time began here. They didn't exist before. Energy and matter and everything within space did not exist before, if you can call it before, because there's no time, unless you want to assume some sort of hyper time. There's like, or super time, super hyper, whatever. So like another time, but then that kind of takes all this and pushes the question back a step. It's just, you kind of have to just do this again, but within hyper time, so it doesn't actually solve the problem. So space, time, matter, and energy, that's what the universe is. None of this existed prior to the Big Bang. The laws of physics didn't exist yet, because it's kind of the laws of physics don't prescribe, you don't have all the atoms and elements, everything saying, like, reading their rule book and being, okay, this is what I have to do now. It's just they do, and the laws are what we make to, like, scientists have studied this stuff, and okay, this is what the elements do, atoms and molecules do. I'm going to write them down because this is what they do every time. We're going to call it a law. So it's not like a law like we have to follow the laws of the road or whatever, and we can break them. These laws are the way the things behave by their nature. But so none of that existed. So that means if none of that existed, then whatever produced them must have none of these qualities. So space without, doesn't take up any space. Doesn't exist within time, timeless. So that would just become eternal in its own way, because time is just I'm going to use the word immaterial, but everything's immaterial with this thing. So there's no matter, no energy, no space, no time. So what could fit those criteria? There's not many options left open to us. So we'll whittle down to abstract objects, and I'll come to the next bit in a moment. So abstract objects would be like you could call them platonic objects, where you're sort of mental images of a thing. Like, does a chair exist if we delete all the chairs in the world, but can still think of what a chair is, and all that. So this is a concept, abstract objects, thoughts, that kind of thing. They're not really material in that way. So there's that option, but those have to come from a mind. They're within a mind, and we could say that a mind doesn't have to be material. Like, a mind could, in Christian theology anyway, and probably a lot of theology, the mind and spirit are almost synonymous. They're very much the same thing. So this is kind of where a big argument between naturalists, materialists, and believers in whatever faith are, is that believers would put mind prior to anything natural, whereas naturalists, materialists, and so on, they have to say that the mind is an emergent property of the material. So one group have matter exists first and mind comes from it, whereas the other group, no, everything is mind first, and then matter can come from mind. So that's a big debate going on, evidence seems more in the mind first camp, as far as I can see. Just, you know, you got a pile of rocks, how's that come into life? Very, very straightforward, really. Whereas if you've got a mind capable of thought, capable of creation, you know, you think of a thought, you've created that. That's a thing that exists now. That thought exists. So mind creating stuff makes more sense than a puddle of mud being struck by lightning and then now it's alive. There's no sense there. So we've got the other option would be numbers again. So like we said, mathematicians believe numbers are this kind of eternal, abstract, existing thing. But they don't have any creative power. They are, again, they're descriptive. They describe the relationship of objects, that, you know, having single objects, multiple objects. They just describe the relationships of how they work. But they're not a creative force. So really we're brought back to the only option we've got out of the options of the abstract and the immaterial is consciousness, a mind. So a powerful conscious mind that creates the entire universe. Just a very, very simple definition of what God is, isn't it? Again, it doesn't have any of the specifics of a particular religion, but that's not what this argument's trying to do. It's just getting to this conclusion of, okay, some supernatural mind is the source of everything else. And I didn't like using the word supernatural there either, actually, because if this is the case, then really the only natural thing is this supernatural. Everything else is supernatural, because the natural, the first and the most basic necessary existing thing is this creative mind. That is nature itself. It couldn't be more natural. Everything else it's brought out is nature creating. So there we go. So here we go. So yeah, there we are. Kalam, you have to extend it out. You've got the universe as a cause. What are the options? Science is telling us the multiverse is out. Science is telling us the big crunch is out. So what have we got? If we take away space and matter and time and energy, not a lot of options, and only one of the options makes any sense, and that option is the supernatural creative mind. And a supernatural creative mind that's capable of creating a universe is just a way of describing God, isn't it? So there's that one. The Kalam. And I think that's pretty airtight, actually, the Kalam. Like I said, they're built on the premises of some of the strongest science we've got. Premise 2 also has the... like we was talking about with the contingency, it has explains how an infinite regress isn't going to work. You can't have an infinite regress because you have to have a beginning point. So they can kind of work together, can kind of back each other up. One more we got here. The fine-tuning or the teleological argument. Now, so premise 1, premise 2, conclusion again. Premise 1. The fine-tuning of the initial state of the universe is due either to physical necessity, chance, or design. Premise 2. It's not necessity and it's not chance. So conclusion has to be design. So what this does is it gives us 3 potential options. It's exhaustive. There aren't any more options. It couldn't be anything else. Then rules out 2 of them. If it's ruled out 2 out of the 3, it's got to be the other one. So those premises are doing the premise 2 is doing a fair bit of heavy lifting, because obviously it doesn't explain itself. But premise 1, what's it going to be? Is it going to be... well, we should probably... What is fine-tuning to start with? Some people get this wrong, what fine-tuning actually is. So fine-tuning is at the beginning of the universe, at the Big Bang again, going back to there are all these, the universe has these things called cosmological constants, and I've got an example of one here. Where did I put it? Oh, let's move you down here. So this formula here. This is gravity. This is what gravity looks like. So you've got F is the force between objects. G, the gravitational constant. Now this is the important bit, the important number. And then you've got all the other calculations there. So we're looking for the force. M1, the mass of an object. M2, the mass of an object 2. So the things that are pulling, R, the distance. Okay, so M1, M2, and R are variables that you like. So the mass of an object 1 could be the moon, the mass of an object 2 could be the planet Earth, and then R is the distance between them. But we could be looking at any two objects and any other distances between those. So these things, all these numbers can change, but the gravitational constant is always that number you see there, 6.67384 times 10 to the power of 11, or minus 11, is that right? So you got, yeah, that's strange. So this very, very specific number. And now this is just gravity, okay? Depending which scientist you ask, there could be 20 of these numbers. There could be 140. So there's a lot. So this is talking about this number has to be this way. There might be a little bit of wiggle room. You might be able to go to 6.67385, maybe. No, probably not actually, because that times 10 to the power, that'll mess that right up. So it might be, you can't move it very much. You can't move it very much, otherwise gravity will not work. Gravity could, if you touch it a little bit, gravity will become too strong or too weak, and that will stop other things from happening. If it's too weak, our basic molecules won't be able to come together to form anything. Like things won't be able to react and create, stars, which would create other things and start this chain event. And if it's too strong, then they're going to come together too quickly and just destroy each other. So it has to be this perfect balance, so we can get things reacting correctly and things holding together correctly, and the universe just not imploding on itself. And yeah, like I say, there's at least 20 of these constants. Do I have any of the others? I thought I had a list somewhere. I don't know where I put my list. Oh, hello, there it is. So you've got strength of gravity, like I said. There's the strength of the entropy, so that's how fast things break apart. The force of the Big Bang, so how fast things expand. Density of matter in the singularity. Acceleration of the expansion of the universe. The speed of light is one. The action of quantum mechanics. The nucleic strong force. So this is what holds atoms together. So if you didn't have atoms being held together, you're going to get nothing. Nucleic decay. Electromagnetic interaction. Mass of things like electrons, quarks, neutrinos. So that's just a few examples. I said 140. I've said 105 on my note here, so I think I over-remembered. Unless they've added, I think they may have added more to the list. But yeah, at least 20, anywhere between 20 and 105, depending on which expert is working on it. So that all of them have these weird specific numbers, and they have to be exactly the way they are, or the universe doesn't exist. And that's what fine-tuning is. So a lot of people think fine-tuning is more like you would like a mechanic would put it. He's built the car and now he's just adding the finishing touches. That's fine-tuning. It's not like the mechanic. It's this beginning of the universe constants, and they're so precise. So would that be something that had to be that way? Is it complete luck, or was it designed? Now, design makes sense. Design makes a whole lot of sense. It's very specific. Like, okay, you can imagine some super intellect God saying, okay, things have to be exactly like this, and this has to balance this one, and this, if this is stronger, this one has to be weaker, so they balance each other out, because otherwise, because there's a lot of interaction between these things as well. And so it's not just the fact that these numbers are the way they are. It's that they're the way they are, and they work with other numbers all together in unison. So there's a whole other layer to it as well. So it's very like a well-oiled machine built from the beginning. So physical necessity, well, we know it doesn't have to be physical necessity because the entire universe didn't have to exist anyway. We've got the Big Bang Theory to say the universe was beginning. The universe didn't always exist, so there's absolutely no necessity. How could there possibly be a necessity when the entire picture doesn't have to exist? So it's not that. So chance. So like I say, we've got at least 20 of these really, really specific numbers. This is like, you throw a dart at a board and it has to hit the exact spot. And you have to do that 20 times in a row. Odds are very, very slim. And that's just a dartboard. Like these numbers are crazy. Like the 10 to the power of there's another one I've got, isn't there? That's a really good one. So the chance of entropy existing in the form it does is 10 to the power of 10 to the power of 123. So that, I think if you started writing that down as in 1 and then 0, 0, 0, 0, it might take the rest of your life to write down all the zeros. You might not even get there. It's just a ridiculously big number. So it's a dart at a dartboard, but the dartboard is the size of the universe. And you have to do that 20 times in a row without fail, or the universe doesn't exist. Everybody dies. It's no good. So chance seems to be out, especially when you couple it with who was it? Where we go? Here we go. So William Dembski has in his book The Design Inference. He took the number of particles in the universe, the maximum, so that's 10 to the power of 80, the maximum possible number of changes per second a particle can go through, so that's 10 to the power of 45, and the number of seconds that the universe can maintain itself before either going into eternal expansion or the beginning of a crunch, which is 10 to the power of 25, and multiplying those numbers together gives us a good probability of what odds would represent physically impossible. So 10 to the power of 80, 10 to the power of 45, 10 to the power of 25 multiplied together makes 10 to the power of 150. Now that's pretty close to what we had for entropy. No, it isn't. The power of entropy is way worse. So 10 to the power of 10 to the power of 123 is entropy. 10 to the power of 150 is impossible. So you've got 10 to the power of impossible for entropy. That just rules out, and that's one of the 20. One out of 105. It's not going to be luck. It just... Science seems to tell us that it is impossible that this would happen by chance. So it's not chance, it's not necessity, so it must be design. And who designed it? God. There you go. Finished. Really, really easy. So how people try to get out of this one is, okay, wasn't necessary because the universe, you can't have that. But so maybe there was chance. Maybe there was something else involved. Maybe we're part of an infinite multiverse. So if there's an infinite number of multiverses, then the chance thing, that becomes... it's not impossible anymore. It's certain, because one of these multiverses is definitely gonna, create. So obviously the problem with that is there's no evidence whatsoever that a multiverse exists. Also, comes back to what we were saying about the, the beginning of the universe and all that sort of thing. All the models have been looked at by Vilenkin and so on. It's like no, where it doesn't apply. It doesn't apply here. It's just not going to go. And then if we're talking about the multiverse, we can also come back to the Kalam. The Kalam's talking about a beginning. We looked at contingency. Contingency says you can't have an infinite regress. So even if we do have a multiverse with a huge number of multiverses, there must have still been a first one. So all the multiverse does is take this question and push it back a few steps. It could be a few million steps, however many universes are in this multiverse. But we still get to the problem of a cosmic beginning. It's just now a beginning of a multiverse instead of our single one. So then we come back to this. How fine-tuned is the multiverse? Is there some sort of machine that's churning out all the universes? And it probably makes more sense for that machine that's churning them out to have this mind and be immaterial and be spaceless. And so if you don't take this on its own, cumulatively together, they back each other up. So they fall onto each other, and you get back to God again. So the strength, the contingency, the strength of that one is that it doesn't rely on temporal beginning so much. It could be possible that the Big Bang is disproved and we go to an eternal universe, but the contingency doesn't rely on time. It just relies on sources producing other sources. So there can be an eternal universe, an infinite universe, and the contingency still applies because it's still that first domino that makes everything else come from it. This one, the multiverse, just we go back to the Kalam, because the Kalam explains the cosmic beginning that the multiverse requires, because in past infinites are impossible. Because essentially, if we'd had an infinite past already, infinite time had already passed, then today should have happened an infinite time ago. How is today happening now? We've had an infinite time to get here. So why hasn't it happened already? Should have happened already, because we've had an infinite time to get here. So that's a huge problem. We can't have had an infinite past. We must have had a beginning at some point, and now we've sequentially got here. And that there's not really any way around that, as far as I can tell. Okay, I'm not sure how long I've been going, and I can't remember where I was going to go next. Not you. Oh, yes, I was going to give a brief mention to the anthropic principle, which I don't have noted down. Or do I? No, I don't. That's something else. So the anthropic principle, sort of similar to the fine-tuning, is the idea that things seem to be designed in such a way that it's very beneficial to us specifically. So this is talking about things about the where our galaxy is located in the universe. We can do cosmology. We might not be able to do it in other places in the universe, because we might be too crowded. We wouldn't be able to see very far with our telescopes and so on. But where we are, we've got a good view of stuff. We can see other galaxies and so on, and that helps us to study things and helps us to understand more and helps us to grow in our knowledge, and things come out of that. We've got this planet that is so unique. It's and yeah, I'm gonna bring that up now. Here we go. Why are you there? So the uniqueness of Earth is just, it's like another level on top of the fine tuning. And if this is just a short list of things here, but there's a lot more than this, of reasons why the Earth is so unique, and why, even though they've been looking for a good while, they've not found another planet that is habitable. They found some that are close, but nothing that can do everything that Earth does. It makes Earth so very special and unique. Like, why is this one planet out of this whole wide universe the only one that's got life on it? You'd think if we were talking about a universe made with chance, this, I mean, is a very common thing. Like, the universe is so big, it's huge, there must be another planet out there that's got life on it. But that assumes naturalism, the natural processes of like evolution and so on, and whatever it was, abiogenesis, a muddy puddle being struck by lightning and things started crawling out of it, or, microbes anyway, but single-celled organisms just formed because water and lightning mixed, whatever is. They don't know what happened because. But if you've got that naturalistic, materialistic idea of okay, everything's got a explanation in that realm of nature, then why wouldn't there be other planets with life on? Whereas if you got the theistic view that maybe the Earth is just the only planet in the universe with life on it, this evidence kind of weighs in favour, because you need all of this stuff in place for life, and there's a lot of coincidences, and it's this kind of, this is more like, so like the fine tuning we were talking about before is preloaded, whereas this is more like the mechanics fine tuning potentially, which comes later. Like, okay, now if I move this here, turn this knob, and now things fit, and it's going to do the thing I want it to do. So we've got the planet; it's just the right size. We've got the magnetic field. We've got Jupiter nearby that's kind of protecting us from meteors. So a lot of meteors that would come and hit us get drawn over there and destroyed over there, and they don't cause us any harm. Our moon is just the right size. So this, like I say, this is not an exhaustive list of things as well. So it's a huge amount of coincidences that, again, if it was just one or two, maybe it's luck. But if it's because it's so many, it doesn't look like a coincidence anymore. Lots and lots of coincidences start looking like it was on purpose. They're all geared towards this final goal of like people being here, living, intelligent things being here, and that's it. There we go. So, I feel like I'm forgetting something. Gravity, come back. I feel like I'm forgetting something, but if I, again, totally unscripted. This is all, I'm on the fly with a few notes put by to help me along, but there we go. Proof of God from space. And I know that was a bit, proof is, like we said earlier, proof is what convinces an unreasonable person. But in real terms, proof is not really something that exists outside of mathematics. 1 + 1 is 2. You can't argue with that. But any kind of other science or history or whatever, it's all kind of, you can get tons of evidence and it kind of looks like proof, and that's where we are. The evidence is so heavily weighted that you might as well call it proof, but you can't actually technically call it proof because evidence and proof are different things. But yeah, but I mean, Vilenkin was talking about proof when it came to the Big Bang, because he was talking about there's so much evidence here that you can't deny it. I mean, you can prove a lot of things. Like gravity exists, that's undeniable, isn't it? But it's just how it works and stuff. That's all the theoretical stuff and so on. And I'm just stalling for time a little bit, just in case I remember whatever it was I forgot. But no, I think I kind of covered it. I covered things kind of briefly. I wanted to fit this into about an hour at most, so I zoomed through things. But yeah, there we go. I think that was 4 reasons to believe that God exists. They make this cumulative case as well. So each individual one stands alone. Each one gets you to God as a creator, as a designer of some kind. Doesn't get you to Christianity. Doesn't intend to. Not a problem. Because once you know God exists, a creative mind exists, supernatural, extra-natural, mega-natural mind, then you can start thinking about, like, okay, this creator exists, maybe one of the world religions has got more information on him, or her. Let's explore those, see which ones match up. So that's you get to Christianity a few steps down the line, but that's fine. That's fine. That's how things work. You don't have to have the whole package in one theory. So there we have it. Proof on a strong day, just very, very strong evidence on a bad day, and could briefly, I think briefly, a lot of the responses people give to these things just amount to pretty much, oh, this is just a theory at this stage. We don't know for sure. It's not 100% proof. There might be a bit of wiggle room, and in that wiggle room, I'm sure we'll find that naturalistic answer we want. And that just feels so much like blind faith. I've kind of laid out this step-by-step stuff. Like, okay, you start here, and then you get to God by a reasoning, by deduction, by using all the available evidence that we have and putting it together to make a theory that fits all of the information and explains everything really neatly. And it's a perfectly wonderful picture that not only does each individual argument work solo, they back each other up and they build on each other, and then you can put the moral argument on that, and then you can put Christianity on top of that, and it all fits so neatly and nicely. Whereas the skeptic's going to have to dismantle each and every one of those based on, but I don't know though, and I don't really have any working alternatives, but one day I'll find one, but I have to deal with each one of these individually, even though it's a really nice, neat puzzle that fits together. And I'll just take one puzzle piece out and say, well, this is wrong because of this, and then this one's wrong because of this, and you gotta do a lot of work to dismantle this whole thing that just makes all the sense and fits all of the evidence and all the reasoning and all the logic and all of the best science and all of the best history and everything. And it's a blind faith position, because you don't have any reason to, apart from a predisposition to naturalism or materialism or something in that camp. That's where you're starting in that camp. Well, it's got to fit because this is where I am. That stuff doesn't agree with me, so that stuff must be wrong. It's like being in the flat Earth camp almost. It's like, I know the Earth is flat. I know it is. Forget all of the evidence. None of the evidence matters because the Earth is flat, and I know it is. It's like, and I'll get around it because I'll do a bit of science, and then I'll disprove all of the evidence that shows that the Earth is round, because because I know the Earth is flat. I feel like that's the same thinking going on there, and that's not healthy. Whereas, this stuff here, it lets you follow things where it leads. Was looking at the Kalam there, the universe has a cause. So okay, let's consider what they could be. We'll consider the multiverse, but the multiverse doesn't work because of X, Y, Z. We'll consider aliens. Well, the aliens are still part of the nature. It doesn't work. But then you get down to God, and that's like, okay, something that fits all of the data. And there we have it. So I think it's as close to a proof as you can possibly get outside of mathematics. And there we have it. I'm going to stop there. I think I've said enough. I think I've done enough. And I might do further videos on these. I'm sure I've done videos on some of them already where I do them properly with due diligence and scripted and all the information ready to hand, instead of this kind of rambly trying to hope that I cover it properly off the top of my head, off the cuff kind of thing. Although these are fun to do. I like these, but I do really want to do more in-depth stuff. But the information's out there. If it's not on my channel, it's on Reasonable Faith, or it's on Reasons to Believe, or it's on Inspiring Philosophy, or one of the other big ones. Go to those guys first for this kind of thing. And I'm going to leave it there, and hopefully I'll see you on the next one. Amen.